Okay, in this module what we're going to be covering is what I'm calling data integrity. What we're going to be talking about is write concerns, and these were covered in M102 by Dwight. We're going to go into a little bit more detail. I'm going to show you visually how some of those write concerns actually happen, seeing how visually and over time write concerns are actually acknowledged and used in MongoDB can be quite an informative thing. And then I'm going to talk about 2.4 changes because some of those had not been finalized when Dwight recorded M102, and I'm going to go over some of the 2.6 changes that are coming in as well. Quite significant changes in both of those versions, so stuff to be aware of for certain. So let's start with the default write concern. Now, first of all, the default write concern is W1. So what does that mean? Well, it means that if you, with that default write concern, you will get an acknowledgement that a write has actually happened, and that write is a write in memory. So let's have a quick look at what that actually looks like, and we'll expand on these diagrams as we go on. Okay, so what we've got here is our driver and our MongoD, and obviously there may be more advanced things involved here. You might have a sharded setup and everything else. We're going to keep things simple for illustrative purposes. So what's going to happen here is we're going to see a write being sent from the driver to the MongoD. This red section here is the MongoD applying the write in memory over time. And this time is the sort of x-axis here, if you like. So as we go further to the right, the more time has actually gone by. So obviously this is quite a short period of time. Receiving a write and writing it into memory doesn't take very long. But the key piece here is that immediately following the write, the driver will send a getLastError call, which I'm abbreviating here to GLE just for brevity. And what will happen is the MongoD will receive that getLastError call, and it will respond and acknowledge the write following that getLastError call as soon as it's actually been applied here. So once the application has taken place, you get your acknowledgement, which I will write in as GLE response. Okay, so now this is the default, and it has been for quite some time at this point. I think more than a year at this point. The old write concern, which has not been the default for quite some time, was W0. What W0 was basically an unacknowledged write. So it looks exactly the same, except remove these GLE calls. So there'd be no GLE getLastError call sent by the driver, and hence there would be no response. Assuming the write actually made it, it would be applied in memory by MongoDB and eventually persisted to disk. But there would be no acknowledgement sent back. There would be no check to see if that write was actually successful. So that's your W0 unacknowledged write. We switched to W1 quite some time ago at this point. So if you're still using the old constructor or an old legacy driver, recommend upgrading or, of course, setting your write concern to W1 yourself, just to be absolutely 100% sure. Now, just to note, there is one other sort of odd version of this, which is not a default anywhere, but you can actually set it. So you can set W to -1 in your driver. And if you do that, you won't even acknowledge errors. So you ignore them, you ignore errors, and it's not something that you should be doing for any normal operation. So it's in there, it's in the driver, but basically not recommended. Okay, so we've covered the default, W1. We've seen the operation applied in memory, the getLastError call made by the driver and then acknowledged. But what other write concerns are there out there? There are quite a few. I'm going to cover the main ones here. First of all, in replica sets, you can, of course, specify a W integer higher than 1. So you can put an integer into W where the integer is less than or equal to the number of members in the set. If you have a 3-node replica set, you can have various W options. You can go W1, the default, W2, which would mean that the operation actually made it to 2 out of the 3 members of the replica set, and W3, which would mean that it had made it to all of the members of the replica set. And there are some aliases that we're going to cover for these things so that you can have the same write concern regardless of the number of members of the set, but those are your valid sort of integer values. W3 here would be quite dangerous. If any of the members of your set went down, you would no longer be able to satisfy your W3. So generally people are going to, for the safer option, make sure that it makes it to at least 1 secondary go for the W2. So let's see what W2 would actually look like here and do that visually. Okay, so similarly again, we have our driver, we have our MongoDBs. In this case, it's a 3-node replica set that I mentioned before. And in this case, what I'm illustrating is that this third node is a little bit delayed. Maybe it's slow, maybe it's got a slave delay on there. But for whatever reason, it's going to take its time in actually getting the operation from the primary when it's being replicated. But that's okay, because we're going to use W2 here. And what we're going to see this time is we see the write comes into the primary, gets applied. The driver immediately follows that with the get last error W2 call to say, please notify me when this has successfully made it to at least 2 members of the replica set. Once it has been applied by the primary, it is then of course free to be replicated by either of the secondaries. In this case, we have this middle MongoD here that picks up that replicated operation and applies it itself. And then once that application has been done, we get an acknowledgement from the secondary to the primary that that has actually happened. And this is sort of your sort of pseudo GLE response, right, via the primary. So then it says, okay, I'll acknowledge that write has actually happened. And then finally, the GLE response of OK1 is sent back to the driver without any errors. So you can see you move from having this application in memory on the primary being your only factor in deciding how long it takes to get a response to being 2 of those, and of course there's any replication delay, network lag between the primary and the secondary here. That's going to extend the time between sending the write and getting the response here for the driver. So you can see how adding a W2 concern is most definitely safer. You've got the write on 2 separate nodes, but it is going to add some overhead and some latency into the response time for a particular write. And you can imagine that if we'd set W3 here instead, what you would have got is all 3 are up, so it would have potentially succeeded, but until this replication happens, you wouldn't have seen this GLE response. So this would have to replicate, be applied, the response would have to go back to the primary, and then you'd see a GLE somewhere out here to the right, a response somewhere out here to the right when it was finally replicated to this third secondary. So one slow node is going to make a W3 quite slow. Now, a couple of things to mention here. I mentioned that there were some aliases for this. So the alias, if you like, for W2 in this particular scenario where you've got 3 MongoDs in a replica set, that would be W majority, which I think Dwight mentioned as well. The calculation there is pretty straightforward. It's data-bearing nodes, right? So in this case, all 3 of these actually have data, and none of them are an arbiter. So your majority is going to be your data-bearing nodes, and the logic for working out what majority represents, very similar to working out what a majority represents during an election. So we covered that earlier on, the strict majority rules, 2 out of 3, 3 out of 5, 3 out of 4, which is an interesting potential issue, right? So you 3 out of 4, if you had 4 data-bearing nodes, you'd need 3 of them to get the result before you get an acknowledgement. So just to be aware that for simple setups like this, which is 3 data-bearing nodes, majority is equivalent to W2. And W majority is actually also what's used when doing a chunk migration, which we covered earlier on. So that calculation based on the number of data-bearing nodes in a replica set and used during chunk migrations as well, considered as sort of a safe replication to the whole cluster, as it were. There is another alias, again not often used. WALL is another alias. In this case, that would map to W3 and has the same sort of caveats and problems that you might see with W3, right? Any one node being slow or any node being down, and WALL in this case, which maps to W3, is not going to return, is going to give you an error. So use if you wish, but use with caution WALL. So W majority, certainly a recommended sort of safety net for any given particularly critical piece of data that you want to write to a replica set. WALL, although you can use it, is going to be fraught with hazard.